The Hangout is now live, Mark. So number 20, this is anniversary edition. Together with me today, Mark Stacey. Mark, you are an expert in PDW, but before that, a few words for you. Who is Mark?
So, to introduce myself, I run a company called Apelion Software. We're focused on the BI industry, SQL Server, and of course PDW, the Parallel Data Warehouse, is one of the things that's a very key focus for us. You know, we were the first PDW partner in Africa. We implemented the first and second PDWs in Africa, which we're quite proud of course.
Yeah, of course, absolutely. So together with you, we've chosen the topic of PDW. And I wanted to ask you to join me for this because I don't know anyone else who have touched this technology so much. So how many projects you have with PDW now?
So we've actually only done 2 projects with the PDW. We've done some prototypes and we've done some software development on the test kit that we had. And so we've done a lot of work that's internal, but it's really 2 client projects that are live.
Okay, so what you call, I heard your session, I was in one of your sessions on PDW, and you said that PDW is a strange beast. Why is it strange? What is PDW?
Okay, so if you think about the evolution of computers, let's go back a few years when your processor was really a single-threaded processor, right?
Yeah.
The way you made your applications run faster is you made your processor go faster and faster and faster and faster.
Yeah.
And this gave you good performance, and then we hit a wall and we couldn't make the processor any faster. So we started to get these multi-core processors. Right? And this is symmetrical multiprocessing.
Yeah.
Now, again, we start to hit some walls with symmetrical multiprocessing. So what are those walls? Big one, SQL Server people will know this, is I/O. Right?
Yeah.
Is the hard drive giving you enough I/O to actually let you use that full CPU? Generally speaking, unless you have a very high-end SAN, often no. So now the PDW is a way of solving that and letting us also increase how many CPUs we can hit, how much RAM we can use, and also how fast the I/O is. So it's what we call massively parallel processing.
Yeah.
So instead of just sucking all the data from one drive and dishing it up amongst multiple CPUs, we distribute our data across, firstly, what we call distributions on each machine. So we say, let's cut our data up and put little pieces of it on different storage, and we've got multiple machines with that. So now when we kick off a query, we're kicking off actually 16 queries in the smallest version of the PDW against different tables, each one of which has its own storage, its own RAM, and its own CPU core, and then we're putting them together. And this is what we call massively parallel.
Yeah, absolutely, makes sense. And the PDW in general is an appliance, right? It's a huge, humongous box with everything that you need. Right, so have you heard something about the new version, the new edition, let's go this way, of PDW? I heard that they call it now ECL or something?
APS, Analytics Platform System. So, okay, this is where the PDW starts to get quite interesting. If you look at massively parallel processing, it's strong at certain things. So it's very strong at processing structured data. Now, that's great, but we all know what's the big term today? It's big data. Whether like it or hate it, it's the big marketing term. And big data is often about unstructured data. Now, PDW, you've got MPP, you have to have structured data. It gives you a part of the solution, but it doesn't give you the whole solution. The analytics platform system says, let's take the PDW, let's take its massive power, but then let's actually also put in a region that's a Hadoop region. So now what we can do is we can actually issue PDW queries, and if the data's in Hadoop, the user doesn't need to know that it's in Hadoop. He issues the query, and the PDW handles sending those queries out and retrieving data off the Hadoop file system. So now you're starting to get the benefit of being able to query data that you haven't loaded into a SQL database.
Yeah, so in general, we now have, I heard and I watched the session from TechEd, we have this amazing technology that's called Polybase, which allows us to run T-SQL queries against HD Insight.
Yeah, and that's what I'm talking about with the PDW issuing those. So Polybase is the glue that sticks together the PDW and the Hadoop region. So HD Insight, what's interesting about that, the previous version of Polybase, your Hadoop region had to be baked into your appliance. Now with the latest version of APS, you can actually have your Hadoop region sitting outside of your appliance, which is a very interesting sort of additional capability.
Okay, so you can have this in Azure, right?
Exactly, you can have it in Azure. So, and it's maybe just a convention. When we talk about the Hadoop region, then we're talking about what's in the PDW. As soon as we say HD Insight, we mean Azure automatically.
Yeah. Okay. So that being said, you told us on that session that you have faced very interesting scenarios with PDW. First of all, who needs that? Who needs PDW in general?
Okay, so a couple different spaces where you would need a PDW. One, if you have a lot of data. So, of course, let's define a lot of data, because I've had some interesting discussions with people. Somebody goes, wow, my database is so big. And I say to him, okay, how big is your database? No, it's 10 gigs. I go,
okay.
Yeah, not so much. So the first scenario is you're starting to store literally tens or hundreds of terabytes, or even in a big PDW, a petabyte of data. Right now, we know you're not going to just drop a petabyte of data in a SQL Server and have it work. Now, because the PDW lets you split out your data across more and more nodes, without decreasing performance, you start to be able to run queries against much larger data sets and still have very reasonable performance.
Okay.
So that's one scenario where you would need a PDW.
A lot of data. Right. A lot meaning
a lot of data. Trillions of rows.
Okay. The next one?
The next one then is if you maybe have quite a high velocity of data. So you've got data coming in very frequently into your warehouse. So where you've got the advantage here is because your PDW has got this massive amount of processing, what it can do is you're splitting that data up. So when you're writing into the PDW, you're not necessarily hitting it that hard, so you can still carry on querying the PDW while you're loading data into it. So it starts to enable this kind of real-time BI.
That's very interesting. That's very, very interesting. So if a company, if an organization decides to buy a PDW appliance, then the question is, what are the gotchas? I will never forget the thing that you said about the distribution of the data between all the nodes. What's that about? And why is that so important? Actually, because it turns out it's very...
Yeah, it's the most important thing with tuning a PDW. So let's think about this for a moment. We're saying we're going to split the data up across this appliance. Now, how do we split the data up across the appliance? You could say, let's round robin it, and we send every distribution one row. Then there are some scenarios where we can trick the PDW into doing that, but I won't go too much into those just yet. Now, typically what you want to do is you want to be able to split the data up in the same way across different tables, so that when you're joining between two tables, they're actually being processed on each node individually, and you're filtering them before you send them back. Let me give you an example. Let's say you've got fact sales, and you want to distribute your fact sales on your customer key. So customer 1 goes to distribution 1, customer 2 goes to distribution 2, etc., etc. Let's say you've got fact cost of sales. Now maybe you load cost of sales when you actually buy the products, not when you sell them, so you can't distribute on customer. So now you distribute on product. Okay, so far so good. I query against my product table, and I'm querying all the different distributions. I query against cost of sales, I'm querying the distributions. Where it becomes tricky, what if I want to join from sales to cost of sales? Now I've got some rows are in this one machine, some rows are in this other machine. In order to actually satisfy this query, the PDW first needs to move data backwards and forwards so that the data sits actually on the same boxes so that it can do the filtering. Now, the PDW is actually pretty good at this. It has technology called InfiniBand as its network. It's a 56 gig per second optical fiber type connection. So you can watch it move data backwards and forwards pretty quickly.
I can imagine that.
Yeah, and it's fun to watch. You're going, let me move a billion rows around. Click, 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 run query, done. Right? That literally, that's sort of real-time kind of speed. And all transparent to the user, but it does mean that you hit some performance issues. Now, there are a couple other things with distributions. Let's say that we've distributed on product. Now, we've smartened up a bit. We've said we're going to distribute sales and cost of sales on product. Great. Yep. What happens if we only have a couple of products? So we only have 5 or 6 products. Well, if we only have 5 or 6 products and we've got 16 distributions in a small PDW, we're only ever going to be able to hit 5 of those distributions. So now we're getting 5/16 of the solution. Okay, what happens if we've got 100 products, but we filter for 1 product? That query is going to be a little bit slower as well, because it's only coming from 1 distribution. So you generally need to think about these distributions. There is a rule of thumb that says you should have at least 10 times as many discrete rows in your key as you have distributions. It doesn't always work, because you might have one massive product and a lot of other smaller ones, like Coca-Cola. You have lots of Coke, lots less Sprite, a whole bunch of other products not that many people drink.
Makes sense. So the general rule here is that you have to know your data very well in order to distribute it.
You absolutely need to know the data. There's also a couple other tricks with it. So let me give an example of one optimization that we had to do, which is very counterintuitive to a SQL person. So we've got customers, and we've got accounts, and let's say we've got a transaction table. Transaction table has an account, but you generally wouldn't actually put your customer ID on the transaction table as well as your account, because that's redundant, right? You don't need to do that. But in this case, we had other tables that we wanted to distribute on customer that weren't actually at an account level. So what we did is we actually added this additional customer ID to the transaction table, distributed it on customer, purely so when we're joining to other tables, we had the same distributions, we can get better query speed.
Okay, so that's, you are tricking, actually, you are cheating for good, of course.
Yes, you're cheating.
Yeah, that sounds nice. So Mark, that all sounds pretty good. So we have all the power on the planet, right? So we have quite a lot of power. We can now distribute the data. What are the limitations? What are the limitations that we can face with PDW? What is different? Microsoft says to people that that's SQL Server, but what's exactly inside SQL Server?
So there are some limitations. Now, just so that everybody who doesn't work PDW understands, each one of those individual machines on the PDW is actually running SQL Server. So there is actually a SQL Server instance on each one of the nodes. And then what sits on the control node is what they call the data movement service, which actually then interfaces between the different SQL boxes. So what that means is we do have the full power of SQL Server underneath the PDW, but that data movement service does have some limitations. So limitation number 1, data types. There are some data types that just don't exist on the PDW. So CLR, of course, right? Anything that's a large binary object, because that data movement service has to allocate RAM and move data backwards and forwards. There's also another little trick that people might into. So, Boris, tell me this. What's the difference in performance between a varchar 255 and a varchar 4000 with only 255 characters in it on a SQL server?
With only 220?
Yeah. So they got the same data, but somebody's been lazy and made the varchar too big.
It will not be that much, right?
On the SQL Server, very little difference. On the PDW, it can be quite big, because that data movement service that moves data backwards and forwards always allocates the full amount of memory for the size of the field. That's more efficient for it, because then it's spending less time trying to work out how much memory to allocate for each row. It's got fixed row sizes. So if you've got a varchar 4000 column, you're actually using up a lot more memory on the data movement service and slowing down the data movement. So that's one thing to keep in mind. Little optimization you wouldn't do on SQL Server. So there are some other limitations. So cursors are bad on SQL Server. Got to tell you, cursors are even worse on PDW. You don't actually have a cursor construct per se. You can do while loops. But as soon as you're doing that kind of while loop, everything's executing on one control node, and you're not getting any of the power of the rest of the PDW.
Oh, that hurts. And you paid for that power.
It hurts a lot.
Okay. And for the administrators, for the DBAs, one last thing. I heard you saying that there is a specific order in which the nodes are rebooted. So the configuration manager or the PDW configuration manager reboots all of the nodes in a specific way.
So the big thing there is don't ever try to reboot any of these machines. Always do it through the configuration manager.
Yeah. Why is that?
Well, so one, if you're rebooting these things yourself, you're going to get problems. What if stuff doesn't come up right? Now, some of the other things that are interesting, if you look at the PDW, it actually runs 2 complete sets of networks with their own Active Directory controllers. So you don't just have one AD forest, you actually have 2 AD forests. The one AD forest runs all of the actual underlying machines on the PDW, right? So it's got the Hyper-V manager, and it's got the actual physical host boxes are all in the one AD forest. The other one is all of the VMs that are running inside the PDW. Now, of course, you also need to have all of those obviously need to reboot in the right order. And then, of course, your different nodes for the PDW. You've got control node, which you've got to query, right? You never ever query the individual
instances,
data nodes. And then you also have a management node that does management.
Okay, so the general rule of thumb is always use the configuration manager. By the way, even if you are in a SQL Server environment, not only in PDW, if you want to accomplish. Yeah, and the last thing, how are you managing this? Because I saw from you and from some demos, there is no management studio inside, right?
Okay, so that's quite interesting.
There is something similar.
There is Management Studio, but there's no Object Explorer. So you can connect Management Studio and you get a query window, but there's no Object Explorer. Now this is one of the things where PDW v2 is so much better than v1. V1 we had to use this tool called Nexus, and Nexus was it's a cross-platform, does Teradata and Oracle and SQL Server and PDW. My personal opinion is just horrible. Microsoft realized it was horrible. You can now, using Server Explorer and Visual Studio, that's what you use in the modern world.
Okay. So, Mark, 20 minutes just gone by. Thank you so much for joining. Where are you at the moment? Because I want people to hear this. This is exotic. Where are you at the moment?
Okay, so I'm going to give you the whole story. You didn't hear the whole thing. This trip has me going, left Europe, came to South Africa, went to Nigeria. I'm now in Kenya, and the next place is Somalia. So that's my trip in a nutshell.
Okay, sounds pretty exotic. And one last thing. I know you are a speaker. I was speaking with you on the same event. Where are you speaking next? Where can people find you
next? Actually, I'm speaking at a Belgian SQL user group on June the 5th.
Okay.
Right, we'll be at the HP venue. So go look up the Belgian SQL Server user group. That's not far from now, a couple of weeks. That'll be the next place that I'll be. And it's PDW I'm talking about.
Okay, sounds nice. Something else planned?
Yeah.
Or is
something else planned?
For now, it's this and summer holiday, right?
That and summer holiday. So yeah, I've got a little bit of a gap until about September. Then September we got SQL Set. Actually, not September. There's Edinburgh coming up. SQL Saturday Edinburgh. Then SQL Saturday Dublin. And then SharePoint Saturday Nairobi. Those are the next 3.
Are you going to be in Dublin?
Absolutely, I'm going to be in Dublin.
I'll see you there. That's the place to end this hangout. So I'll see you there for all of the people that can join. First Belgium, then Dublin. Just go there. Just go there. Okay.
Thank you, Boris.
Okay, Mark. Thanks again. See you soon.
Indeed. Cheers.
Cheers. Bye.